还是我先介绍？Okay, let's begin our session. Let me first introduce our jurist. Professor 门福国 from 中正大学 and Professor 林之渊 from 东吴大学 Professor 白伟武 from 台湾大学 Professor 傅祖仪 from 台师大 and I'm 谢亚维 from 中央大学 Okay, and all the captains, please introduce your member. Let's start from the recorder.
Okay, so I'm Shane Lin from Ridiculous, and this is Lai Yan, this is Yang Shanghang, this is Jian Gui, this is Xie Xiaoxian.
Opponent.
Okay, my name is Hong Wei Zhe from Teacher Newly, and this is Chen Jianchang, Yang Liyu, Lan Bochun, and Liu Jiachen.
Reviewer.
Hello everyone, we are Team Gongtang International Changhang Girls Senior High School, and I'm the captain Zhong Yixing. They are my teammates Si Ru, Jia Ji, Yi Zhen. Thank you.
Okay. The opponent challenged the reporter for the problem. So you have 1 minute.
I would like to challenge number 15 volleyball.
Okay, please, presenters, please write down your name on the board. The reporter addressed the problem number 10. Oh, sorry, no. 15, sorry, 15.
要看慢标吗？
And now it's the preparation of the reporter.
方向我可以过去了。你要看这场。
然后这一届参观这边，你应该稍后
放我，那我先过去，我在楼下等。好，我在这边等。
到后休息。应该可以。有一个是这样会离开。
哦，好。
May I start?
Presentation of the reporter.
Greetings. Today I'm going to report problem number 15, welding bowel. First of all, let's clarify the following statement. When you strike the side of the metal ball containing some water, you can hear a characteristic sound. The sound changes when the water in the bowel is moving. Explain and investigate the phenomena. So here is some key questions and I want to ask is how the characteristic sound is made and what is the relevance between the motion of the water and the sound. So let's take a look at the observation video. We can see the moving bowel and also we strike it and we can also observe some wave which we will investigate later. So here is the theory. We can calculate the natural frequency through this equation. The natural frequency of the bowel, and these are the notations. And for the frequency that contain water, we can calculate by this equation, and this is about the some higher mode, and so. And here is another theory that is describing the bending plate theory, and it describes the speed of the bending wave, and also consider the circular mode, and we can get this equation fixed. So here I will finally answer one of the key questions with my theory. So when the water in the bubble is eccentrically moving, the capillary wave, which originally lingers around the boundary of the water, begin to be pulled in owing to boundary shifting and also the Coriolis effect. And the collision of the waves leads to interference, subsequently impact the vibration. So I will verify my theory through the experiment 1, the capillary wave. So these are the equivalent. The methodology is the mechanism of the capillary wave. We can see because the soap will have a larger shifting, and that will prove my theory. So, and also we can calculate some fundamental measure of the capillary wave. So here is some fundamental measure. We see the wavelength, the wave speed, and the frequency. So we verify this by, we know the frequency of the capillary wave is usually between 10 Hertz to 100 Hertz. So from the result, we can see, yes, it fulfilled some properties of the capillary wave, and also the wavelength, because the wavelength of the capillary wave should be under 10 centimeter, which, yes, it fulfilled this property. And here is the comparison with the water and the soap water. So notice that the orange denotes the soap water. And here is the frequency of not moving bowel, still bowel. And we can see the frequency of the soap is higher than the one with the water. But it might just because some deviation. So we will move on to the moving bowel. For the moving bowel, we can see the orange one is the soap, and we can apparently we can see the frequency shifting, that the soap frequency is much lower than the one containing water. And also here is the capillary wave, since it is around 10 to 100 Hertz. So this is the experiment 2. Though we see some frequencies, but we still cannot ensure if it is capillary wave, since maybe it is from the machine, the noise from the machine. So in experiment 2, I would like to verify if the wave, if the frequency is caused by a machine or not. So these are the equivalent. So we will place an empty bowel on the machine and motivate it into an angular velocity of 14.55 rads per second, and compare the sound we acquired after striking with and without machine noise. So this is the one without the machine. The bowel just just place it and it's still there, and we strike it, we get those frequencies. And for the one that is rotating on the machine, the frequency is here. So we prove that the sound of the noise of the machine didn't impact our result. So here is the experiment 3, the volume of the water. These are the equipment. So here we can see we use the Lego machine to rotate, to make it have like some movement, and then we will use the Python to analyze the frequencies. And this is the methodology. We record the sound under each angular velocity. Afterwards, vary the volume of the water and analyze with Python. This is the case of 10 milliliter, and we can see it is very special since the capillary wave only occurs when angular velocity exceeds 14.55 rads per second, or otherwise the capillary wave will not occur. And we can also see the frequency shifting, and notice that the frequency shifting is very obvious in the higher modes. And for this, we can see the one with the higher angular frequency will have a larger frequency shifting. And we put it in one graph, and we can see, yes, the lowest one, this point is the capillary wave, and for the lower angular frequency, there is no capillary wave, and also the frequency shifting is quite small. So let's take a look at the 14 millimeter, and here is the capillary wave. So the capillary wave occurs after the 2.91 rads per second, and the frequency shifting is more obvious than the one only have 10 milliliter, especially for the highest frequency. So here the highest frequency will have a most obvious frequency shift. And we draw it on the graph, we can see, yes, the frequency shift is much higher than the previous one. And also the capillary wave occurs here. So we can see that the boundary of the capillary wave will vary, and for the more water consists in the vowel, the boundary of the capillary wave will be lower. So the 70 milliliter says the same story. You can see the capillary wave and also the frequency shifting, except it is larger, and the highest mode has the highest frequency shifting. And there's something that I want to clarify is that why we didn't do the higher angular velocity. This is because for the 70 milliliter, if we use a higher frequency, higher angular frequency, the water will spill out. That will interrupt our experiment. So for this one, we can see because we didn't do the highest angular frequency here, so the frequency shifting is not as obvious as the previous one. However, we can still observe the capillary wave, and the boundary is very close to the previous one. So let's take a look at the 100 milliliter. So also the capillary wave and the frequency shifting, and the largest frequency shifting is here. So for the higher volume of water, their mechanism is basically the same. So this is the graph, and this proves this fulfill our expect is that the higher angular velocity will lead to the higher frequency shifting, because we compare this with the one with 70 milliliter, and we can see for the same angular velocity, the frequency shifting in the 100 milliliter is much larger. Okay, so this is the data analysis, and we can observe a linear correlation for these four data. So I have to explain this too. This too is because only little water filled. this means that the only little water filled means that it cannot fill the bottom of the bowel, and which our theory cannot account for. So for the next, and this is the one with the highest angular velocity. So over this, the water will spread out, and also our theory cannot account for this. But for the previous 4 dots, we observe a linear correlation. So this experiment is quite huge, so I will summarize it with the logic. So when the water can cover the whole bottom of the bowel, the boundary condition of angular velocity is larger. For instance, 10 milliliters of water require 14.55 rads per second to motivate a capillary wave. And our theory failed to account for the less water situation. So these are the conclusions. The main factor of the phenomenon is capillary wave, which, just as I mentioned, the first key questions I have just answered it, and the machine sound don't affect a lot, and this is very important for me to clarify the phenomenon. And also the third conclusion is the theory has its boundary. It can't describe the less water situation. And that's all for my report. Thank you.
Question from the opponent.
Okay, thanks for reporting. So first question is, how do you strike the ball?
I use the hand.
Okay, and what's the material of your ball in your experiments?
Pardon?
The material of your ball.
Metal.
What kind of metal? Like an iron or something else?
Yes, the iron.
Okay, so how do you record the sound in your experiments? Using what equipment?
Just phone.
Okay, and how do you check the motion of the water? Because you have used the water speed in your experiment.
Tracker.
Should check water.
To track the water wave.
Okay.
To be more specifically.
And do you measure Young's modulus of your ball? Because you have used the Young modulus in your theory about the inner frequency.
Yes, but that equation is just the purpose of it is just to describe the natural frequency of the bowel, which I have already measured, so I don't have to measure the Young's modulus of the bowel.
Okay, so in the there's page in data analysis in the page, I don't know which page is on the stem is very side. So in here, you think that in the boundary in our near is linear relationship.
Yes, and it also fulfills my theory.
Okay.
Correspond to my theory.
So you have use the form 4 points units.
Yes.
Okay, and for this page, when talking about the V means in here.
Oh, the V means the V means the volume of the water.
And how about A?
A means the area of the bottom of the bowel.
And about H?
H is the height of the bowel. However, in this situation, we don't calculate V divided by A, since the A is not constant. So I will just measure the height of the water, and this is one theory. So I exhibit it like this.
Okay, so about your, because here's the height and the area here. So what's the shape of your ball? Is it just a straight? Or
No, it is not. So just as I mentioned, I directly measure the height.
Okay, thank you.
Preparation of the opponent.
我说直线水的高度是不同的。它不能直线水的高度是什么？它不是这个正方，是基于它是用就更高，给它的高度。你知道一直我把一直全力去。
小朋友 take 4.
Okay, so here are the component from Team Bernoulli. I'm a component from Team Bernoulli, and I got you a post power 15 watt ball. So the problem statement states when you strike the side of a metal ball containing some water, you can hear a characteristic sound. The sound changes when water in the bowl is moving. So the important to explain and investigate this phenomenon. For a focus point of the reporter, he tried to explain why you have falling sound. Also uses some analysis to describe some feature about the sound. And for summary of the report, he used a vibration of water and used some. The reporter hit a ball through the cause of vibration. He tried to describe how big a frequency is, and also the sound, and also a frequency theory. Try to describe how big a frequency is when you strike a ball, and also when the water is moving. Yeah, and also also consider the sound of machine to try to analyze what's the difference between the noise and without noise, and use the theory to describe how big the frequency is during the striking and water moving. I think the reporter and also use the Young measures, but the report said he used the Young measures to describe the nature of frequency. But I think that he could maybe have more detail about the connection between the frequency, nature of frequency, and what itself between its relationship. Also, about experiment, he used a bow made of iron to do experiment, but here he used a hand to do it. So maybe later we'll have some discussion about the method that he strike a bow. And about also using a shaking machine to consider the different parameters. And also use a fighter to analyze the frequency to see what's the difference when changing the different parameters to see what's the different frequency. Also, the reporter have lots of parameters. First is about water volume. The reporter changed different water volume and also strike the ball to see what's the difference between them. Also about using a shaking machine to consider the noise from the machine or not. And the reporter said it won't affect too much due to the shake frequency. And also doing it without moving ball or not to try to do some blank experiment to see what's the difference about the water moving and without moving. So here is the strength of the reporter. He used some theory to describe how big actually the frequency is. I think that is very good constructive idea to try to analyze how in your experiment. Also use some experiment to prove the assumption, to prove some theory. And the reporter has said there's a boundary in the theory, and also the reporter can found it out and try to explain the before boundary and after boundary and why it cannot use this in the theory. Also have some web modeling using of course using the FFT analysis. I think we're going to analyze the sound and the frequency and the feature of a sound. Also use some explanation to talk about nature of frequency and the capital wave relationship. And also use the different parameters to see the assumption and its theory is matched or not. But there's a suggestion for a reporter. I think the reporter could explain more about how he do experiment about strike which position of ball and how it's striking. And also lack of some explanation for the experiment result on report. So I think the reporter could maybe overlay the different parameters in together and try to match them and try to tell about what's exactly different in there. And also they have explained the importance of I think too. And also analysis method. I think a reporter could talk about more about how he used the FFT to analyze it. I think maybe that's very important. And also about the recording way. The reporter used a phone to record, and later we have discussed this method's possibility. But also there's some lack of error bar. So I hope maybe the reporter have dealt several types, or I don't know. So I think maybe we can show some different types of error bar in here. And also I think there's lack of page number. So yeah. And that's all my summary of my report. So let's invite the reporter for discussion.
So may I clarify something? I see in your summary you said that unsuitable fitting curve. So what do you mean by? Do you mean the last linear?
Yeah, I mean.
But
Can you show me?
This is corresponds to the theory. From this equation, the square of the frequency and the ratio of it to the power of 4 will be a linear correlation. So I don't quite understand what do you mean by suitable.
Can you show me the last page?
The last page,
Yeah,
okay.
About you
the-
draw a linear line that page.
Okay.
Yeah. Yes, linear page. Yeah, because it seems that there's some point is not very on linear lines. Also, you have used a foreign points to connect the line, so you think it's enough not to converge your read.
So that is your point, and I think these two dots is because the water is too less for.
Yeah, I know that it's out of your boundary.
Yes,
But I try to, maybe there's a mistake about how the front of 4 points.
So you mean the data is to that is to describe the verify the theory, right?
Maybe yeah.
Okay.
So
You can now move on to the next question.
okay, so first pressure proper statement, please.
Okay, okay.
Okay, the proper statement says there's a character sound. This you play in yours.
So Professor, can we play sound during the tournament? Okay, so okay now.
Yes.
Okay, then I will play it.
I hear you use a slow motion to.
Yes, you are right, but you can
yeah.
apparently you can hear the frequency shifting.
Frequency, you mean the different?
Yes, you can see you can hear that the frequency is lower and then increase back.
So I think the character size is a different frequency.
Of course.
Okay, so can you show me your setup page?
Which experiment?
It's this page.
Okay, this page.
Okay, so in here you said you use a hand to strike a ball.
Yes.
May I ask which position of the ball did you strike on this?
The side of the ball.
Which height? About height? Maybe
Oh, the
height of
the
yeah,
top.
just the top.
Yes.
Also, may I draw use the backboard? So you just this percentage of ball, you just hit it here.
Yes.
And how do you control how big that you?
Because the main focus I want to underscore is the frequency. So this will only impact the amplitude, and that is not I want to investigate.
Okay, so how about this part in that without the water? Do you think it will affect the frequency of your?
No, because the striking, I mean the purpose of the striking is just to motivate the capillary wave. Because usually the capillary wave will stay at the boundary of the liquid since there is like surface tension. But if I strike it and also the water is moving, I can motivate the capillary wave.
Spot. Oh, okay, got it. Okay. Okay, F4. There's a page that talk about the Fourier list of effects. So can you try to tell more detail about what the effect is?
Because the ball is rotating eccentrically, so of course because there is some effect acceleration, so the correlative effect will occur.
So what's the factor to the?
This will give like some kind of equivalence of gravitational field on the horizontal direction. Maybe I can tell you like this.
Okay, so in your video, you show that you try to shake the boat,
And I think
and so
so. I think I can draw how capillary wave. So imagine in the drawing I assume that it is a cylindrical ball, and I think it's okay. Okay, so this will be the bubble, and usually the capillary wave will stay at the boundary of the liquid. But when the bubble is moving or say rotating eccentrically, then the capillary wave, due to the maybe boundary shifting, it will go in the middle and make some collision, and so this causes the characteristic air vibration, so which impact the focus.
what air vibration?
Yes.
But you said the empty space in here, you say you want to affect.
then how do you hear the sound?
I mean, so you think the sound is from the air vibration?
The water causes the air vibration, but if there is no air vibration, you cannot hear it.
Yeah, I know. I mean, so how does it cause the air vibration? How the water cause it? I mean,
Here the water wave will like push the air, so cause the air vibration, or else you will not hear the sound.
You mean push up? But the sound also, I think the sound also can pass through the water.
But you are not in the water, so.
But you use the phone to record it.
But the phone is outside.
Okay. So you mean that the water will cause the air vibration,
Or else the sound cannot.
So the characteristic sound is about air vibration. That's true.
But air vibration is just caused by the water. So the characteristic part is the water. But if there's no air vibration, the sound cannot deliver it out.
Also, I mean, like the air is just a medium to pass out the sound. So can you try to explain more about the mechanism that the vibration during why the frequency will change and the audio vibrations mechanism, the relationship?
Oh, that is just water wave interference.
Okay, so if it puts
The interference
okay,
is the main focus.
okay, and about because you said you cause the water to start flow through when you strike a ball.
Actually, it is because the ball is moving, and strike is just to hear the frequency.
Moving, so your water is just like it keeps strictly moving. We're up and down.
The ball is eccentrically rotating.
I mean the water inside of the ball.
Like maybe we can watch again the video for this one. Okay, this is the slow motion, so we can see it very clearly. You can see, yes, the water, there is, like this, apparently there's water wave.
Yeah.
And it, when we verify it's like a wavelength, and we can see that it's capillary wave.
Okay. So I got. So you just try to search. Okay. Can you show me about your theory page? About how you have some equation to prove your frequency.
Oh, you mean?
Yes, this page. Yes, that's this page. So we're talking about the circular mod in means. What's circular mod?
Oh, then I think I should open another page to explain. Yes, this page. I will use this page to explain the circular mode. So the circular mode is about the plate bending theory, and this is quite mathematic. Yes, it is about math, and so this is for the 2-0, and we can see.
What the 2-0 means in here?
You can just imagine. I can say briefly because it's difficult to explain, but you can just think here is 1 and 2, like node. So yes, this, and also here is outer the plate, and this is inner the plate. So you can imagine two like this.
Okay, I got it. So you just try to describe it. Okay, can you show me about the analysis of using FFT about the different experiments?
Okay. So let's start with the maybe
yes.
water.
Yeah. So about the X is about the frequency of the sound.
Yes.
And about intensity.
Intensity.
Intensity. What is intensity?
You can just understand that as magnitude.
Oh, okay, I got it. So can you tell me why so this is a soap and water one?
Yes, and
why the soap will so this is very why is the soap one or
the origin one is the soap water.
Okay, so why will it become so much range and why is just a change now? Can you try to explain why?
I think this is just on deviation of the experience. Here, this is also a very similar shape.
What's similar shape?
I mean,
this data is similar shape. When you use the same.
I mean, you said the bottom is larger, and
yeah.
So the water has a similar bottom. And yeah, and that's my explain.
Okay, so can you show me about the page about other FFT that you
Okay. The opponent summarized the discussion.
Okay, after having this discussion with the reporter, asking about how he actually strike a ball and reporter to strike a top of a ball. I also said that the sound is due to air vibration causing the characteristic sound. The water is just causing the air vibration. So I mean, I think the reporter could try to explain more about it. And also about the weight of it, and it's important actually to say how power is made. The portion is not pointing here. And also actually about analysis about using FFT. I think that's a very creative way to present a frequency and also the amplitude. And also there's some actually about some theory that using the linear line. And reporter said that he used 4 points is enough to draw out the line. But I think maybe we could try to do more other conditions to say curve more is match the theory. And also talk about the points that didn't match the theories out of boundary. I think the report is very good to know the boundary of the experiments. And this is my summary of my discussion.
Question from the reviewer. Reporter movement.
I want to ask the reporter, you said you calculate the natural frequency of the ball, right?
Actually, I measured it.
You measured, and I want to ask, will the sound change when the striking frequency and the natural frequency of the ball are the same or not?
How do you mean resonance?
When the striking frequency is equal to the natural frequency of the ball, and the sound will be obviously or.
No, it is not related to the striking frequency. It is not relevant.
And I want to ask, how did you define the characteristic sound in proper statement?
Can you rephrase the question?
How did you define the characteristic sound? And what difference between the moving or not moving one?
The difference between the moving and not moving water is the moving water has the frequency shifting, and the frequency shifting causes the sound that you just heard in the observation video is that the frequency will first decline and then increase back to the frequency, so that causes the characteristic sound.
What the reason of the frequency shift?
A capillary wave.
And how about moving? And I want to ask, what difference of the waveform between the stationary and the wavewater? Because you say you use Fourier transform to analyze the sound, and you only analyze the frequency.
Yes, the sound frequency.
And I want to ask, if the frequency increases, then the obviousness of the sound will decrease.
Pardon? Can you
When the frequency of the sound increases, then the obviousness of the sound will increase or decrease.
How do you mean the amplitude? And I didn't observe the amplitude.
And okay, about tone.
Because it's just drag and fall, so the sound becomes smaller and smaller. Yes, I think maybe you could continue to analyze the amplitude too.
How does the angular velocity affect the frequency shift?
The higher angular velocity will lead to the larger frequency shift.
Yes, I know, and can you explain why?
Still, the capillary waves, they move from the boundary of the liquid to the middle, and then they have the interference.
Okay. And how does the boundary condition affect the sound?
Boundary condition. What do you mean by?
Because when you shaking the ball, then the boundary condition will change, right?
I'm not quite sure about what you mean by boundary condition here.
Of the liquid.
The boundary condition.
Yes.
Okay, calculation of the reviewer. the reviewer takes the floor.
Hello everyone, the reviewer Monster from Team Photon, and today I'm going to review problem number 15, rolling ball. This problem statement and my main focus is what factors make the swelling phenomenon and the change of the waveform. There is the review of the report, and in presentation, she calculated the natural frequency of the ball and she calculated the boundary of the plate. And I think she connected with the phenomenon accurately, but she lacked of the theoretical explanation and didn't consider about the damping effect. And in experiment and setup, she changed water volume and shaking frequency and the density of the liquid and the moving water or moving ball or not. I think she didn't directly contact the steel ball and consider the machine noise. And I think he didn't explain the reason that the manipulated variable affect the experiment result. And in data analysis, she observed the wavelength and wave speed frequency and intensity and angular velocity. I think he explained the definition of the data well, and I think he lack of connection between the theory and the data and didn't mention the reason that caused the data change. And there's the review of opposition, and in short question, she asks about the material of the ball and the shaping method and measuring weight and the terms meaning. And I think she indicates the defect of the setup and mentioned the lack of error. And I think he to focus on experiment setup and lack of discussion about the data and the theory and show the Young's modulus in the speech that it is not fixed the experiment. And in discussion, she asks about the air vibration and space Fourier transform and boundary condition and surface tension. I think he connect with short question and constructive suggestions about the experiment, but I think he didn't discuss the connection between the data and the theory. And that's our question 1. I asked how did you define the characteristic sound and what difference of the sound between the moving and not moving ball. And I think when the frequency and the waveform will be different when you move the ball. And the reporter said if he moved the ball and the frequency will shift. And the opponents agree with the reporter. And our question 2, I asked, will the sound change when the striking frequency and the natural frequency of the steel ball are the same or not? Because I think when the frequency is the same, the welding sound will be more obviously. And the reporter said it will not related to the striking frequency. And the next question, I asked how the capillary wave affect the welding sound, and will it change the amplitude or frequency? Because I think the frequency will change more than amplitude. And the reporter said it will change, the frequency will change, and the opponent agreed with the reporter. And our next question is what difference of the waveform between the stationary water and the shaking water, and why they are different? Because I think it is because when the water is shaking, the vibration most will affect the frequency of the sound, so the waveform will also change. And reporter says because of the capillary, and he didn't analyze the waveform of the sound. And there it's about the missing point.
Okay.
Thank you for your attention.
Concluding remark of the
Okay, so I will summarize the discussion. So here's some clarification. When it comes to this, the point is the rate of the water column height, which I think this caused the way I manifest caused some misunderstanding. So I will improve my my skill to exhibit my my research. So the next one is the different sounds to resulted from the frequency shifting. And when it comes to the properties of boundary that reviewer asked, I'm not sure which property is she asking, since I mentioned the boundary so many times and each of them have different meanings. So for the discussion, we discussed about a magnitude of striking force does not influence our discussion, since our main focus is the frequency, especially sound frequency shifting, and it only impacts the amplitude of wave. which I'm not going to inquire into. And the air is the only medium that conveys the wave. The point is the interference of the capillary wave, which I have drawn it on the blackboard. So here is some disclaimer. So generally, capillary wave only exists in the boundary of the liquid. So the phenomenon that the wave moves to the middle is really important, or else the interference will not occur and it will just be a very normal striking bubble. And so this is my rebuttal, and thank you.
Okay, question fire material.
Comment on the effect on this sound when this pole is tilted. I'm saying please comment on the effect of the sound when this pole is tilting the water. The pole is tilting.
Oh, when the pole is tilting, the potential energy of the water will change and also cause some kinetic energy change, and then will impact the interference.
And I think when the ball is tilting, then the frequency of the sound will decrease.
I think when you tilt it, there have different depth of water, so I mean it will affect the frequency too.
What causes the sound in this case?
The vibration of the water and the bubble.
I think because when we shaking the ball and then
No, just the sound.
the sound,
Yes. Even without water, can we hear the sound?
because the tilt angle will change.
I'm not talking about tilting. I'm asking, where does the sound come from?
For me, it's when you strike a ball, and it will cause a sound. But for water,
What's the origin of the sound?
the collection that you hit the ball. When you strike a ball,
Okay.
I think because
Maybe I should move one step back. When you hear a sound, what's the reason you hear the sound?
where you mean where you hear your sound?
Yes.
Well, of course, you use a phone to record, so it's just the air property.
Air vibration, right? What causes the air vibration in this case?
The air vibration.
That's why you hear the sound, right?
You mean the origin of the sound?
Yes.
Oh,
In your case,
it is the vibration of the bubble. Since if there is no water, we can still hear the sound.
Yes.
Yes. So it is the vibration of the bubble.
yes, it's the phone. So what causes the shifting of the frequency shift of the sound?
The interference of the capillary wave will impact the frequency of the bubble.
Yes. So I think the most important part is because of the water moving, the motion of the water changes the vibration mode of the ball, right?
Yes.
I don't see you pointed out in your report. Did you?
No, I didn't.
Okay, thank you.
Any other question?
Just a quick question. I just wondering, when you rotate your ball, that's the center of the rotation is in the center of the ball or
Oh, no,
outside?
it is eccentrically rotation.
Centrical
Yeah.
rotation. Okay. So are you making, do you make sure that when you spin the ball, then the water is spin in the same speed with the ball or different?
I observe extra motion of the water like some wave. So it is not just as same as the bubble.
Any more question?
Okay, one more.
Okay.
The strength of the strike, what do you think?
About hitting a ball, how
Yes,
hard it is.
harder or lighter?
I think when you hit harder, there are some different vibration of your bone, so maybe will affect the frequency.
Do you agree?
No, I think it only impact the volume of the sound, which is amplitude.
So you don't think the strength of the strand will change the frequency of the...
I don't think so.
Okay, thanks, Sam. So now is scoring time for Julie. Ready? Okay. So the score for the reporter. 5,5,5,6,7. The score for opponent. 6,6,6,6,8. The score for reviewer. 5,5,5,7,6. Okay, thank you for everyone. Let's take a break.